Okay, let's give you guys some more practice. So determine if this series will converge or if it will diverge. So press pause and have a go. Okay, so to do this, normally you would consider the nth term test. So you would consider this limit of n over 3n as n heads towards infinity. In order for this to converge, this limit has to be zero. Well, have a quick glance at this. If you look at y equals x graph, it will look like this. If you look at y equals 3 to the power of x, it will look something like this. You can see that as n tends to infinity, 3 to the power of n will be a lot bigger than 3 than just n. So you should have a hunch that this limit here will head towards zero because the denominator will climb a lot faster than this. So you should have a hunch that this thing here, the limit of this, is going to head towards zero. So the nth term test is not going to yield anything. So now we need to consider if this will converge or if this will diverge. We could use the ratio test, but a more efficient method is to use the root test. So with the root test, we always consider computing this value here. So the absolute of whatever you're trying to investigate, and then take the nth root. So if you look at this, n is moving from 1 to infinity. So this will never be negative. This will never be negative. So we can pretty much ignore the absolute sign. So that will then take us to here. So if you look at this now, take the nth root as n heads towards infinity. So this thing here will be n to the power of 1 over n. And then this thing here will be 3 to the, this thing here will be 3n to the power of n here. So this times this will give you n over n, which is 1. So this thing here will take you to here, and then tidy this up. This thing here we know is going to be 3 to the power of 1, which will be 3. So now you should be able to tell that the limit of this, you should be able to tell that as n heads towards infinity, this will head towards 1. You should be able to, well, we've done this many times in the past. If you ever forget what the limit of this as n heads towards infinity, then you have to do this. You should know this, but if you ever forget, then investigate from scratch. You're trying to find the limit of n to the power of 1 over n as n heads towards infinity. Let this thing here be y. So take the natural log of both sides. That will give you this. And then here you've got a fraction multiplying this. This gets multiplied to the top. Blah blah blah. And then here. But by the way, when you get to this stage here, as n heads towards infinity, as n heads towards infinity, you're going to have this thing here will head towards infinity. This thing here will head towards infinity. This is an indeterminate form, so you can apply L'Hopital's rule. So applying L'Hopital's rule, by right, you should map a continuous function on top of this. So you should, by right, you should turn this into a continuous function. So that would be natural log of x over x, and then well, blah blah. We've done this many times before, but so here you've got infinity over infinity. So you can use L'Hopital's rule. So differentiate this, that will then give you this. Differentiate this, that will then give you this. And then it's blah blah blah. The limit of this thing here equals 0. So you're after, it is the y that you're after. So you would exponentiate both sides. So e equally to both sides. That will then give you this. In a way, these two cancel each other out, giving you y. This thing is 1. So going back to here. So remember, you should know this. Try to remember this. The limit of this thing here as n heads towards infinity will be 1. So going back to here, this thing here will be 1. So the limit of this will be a third. So going back to the original question, we were trying to determine if this will converge or if this will diverge. We would then look at the root test. So the root test is us computing this value here. Well, computing this value gave us 1 over 3. Well, when it comes to the root test, if it's bigger than 1, then the thing will diverge. If it's less than 1, if this thing here is less than 1, then it's going to converge. Here we've got something that's less than 1. So therefore, this thing here will converge. Okay.